All right, 8.3.2, we're going to talk about solving these trinomials or factoring them down. We're going to do 3 problems of that, and then we're going to look at how to get these to say equals 0, because when we start solving these, they need to say equals 0. So we're going to work on getting them into what we call standard form. So just a little refresher here, when we have a trinomial, we can factor it down, we can break it into the 2 groups that multiplied to create it by taking our last number. It's actually our first times our last, but this is a 1. And 1 times anything is just that thing itself. So 1 times negative 48 is still just negative 48. So that's why we're just using the last number. If we had a number in front, we would have to multiply that. So if it was like a 2, we would have to do 2 times 48. Okay, and then down below, we're going to put our middle number, a 2. And you can use your chart, but negative 48 and positive 2 would be a positive 8 times a negative 6. And then we write our answers, our groups. We're going to say x plus 8 times x minus 6. Those are the 2 groups of numbers that, when multiplied, would create this. In our next one, we're going to have a negative 8 on top, a negative 2 on the bottom. So my negative 8 came from here, and my negative 2 came from here. And we're looking for what would multiply to make negative 8 and combine to make negative 2, and it would be a negative 4 times 2. So x minus 4 times x plus 2. This negative 4 and this negative 2, that's where I got these from. And the pattern is that it was our variable combined with that, and our variable combined with this. And then for this one, we're going to have 18 on top, negative 11 on the bottom, and that would be a negative 9 times a negative 2. So then I'm going to say x minus 9 times x minus 2. Okay, so that's a brief refresher on factoring. You're going to continue working on that. Let's talk about getting things into standard form. So for standard form just means that we need this to equal 0. Right now, our equation says equals 8. So in order to get rid of that 8 to make it 0, we're going to subtract 8 to both sides. When I do that, that makes it 0. And then this 8 cannot combine with the 3x or the x squared, so it stays separate. So your answer would be x squared plus 3x minus 8 equals 0. That's what you would type into your answer box. So we're literally just moving whatever's on the right side by doing the inverse or the opposite operation to move it to the other side, and I'm going to line it up with its like term if it has one. So negative 5x squared would get rid of that to make it 0. So in red there, that makes that equal 0, but then I also have to subtract. I have to do the same thing to the other side. Think of it like a scale. We have to keep the scale balanced. So 7x squareds minus 5x squareds makes 2x squareds. My 6x doesn't change, and my negative 4 doesn't change. So that's my answer. Very simple, very simple. We want this to say equal 0, so I'm going to subtract 11. Those cancel out to make 0. And then I have my 3x squared is not changing. I have a negative 3x and a minus 11. No like terms to combine. Let's take another look at another one. This says equals 8. negative 8, so to get rid of it, I'm going to add 8 to both sides. That will equal 0 now. X squared doesn't combine with anything. Negative 8x cannot combine with anything. Positive 8 cannot combine with anything. So this is our answer. That is written in standard form. And then from standard form, we would be allowed to fill in our big X. We're not there yet, but we don't start filling in our big X until our equation is in standard form. Excuse me. So for this one, we're going to have to subtract 14 to both sides to get that to be a 0 now. So now I'm working with negative 2x squared plus 4x minus 14. Okay, a couple more examples here. Here I have a negative 2x, so I'm going to add 2x to get rid of it and make that a 0 now. That 2x can't combine with anything, so 3x squared plus 2x minus 9. We want to write them in what we call descending order. So your biggest exponent down to your smallest or your constant term. Okay, last example. Here I have a negative 7x, so to get rid of that, I'm going to add 7x to both sides and be left with 2x squared plus 7x plus 14 equals 0. These cancel out to make 0. Okay, very simple. A lot of these are just doing like a one-step thing to move stuff over. Okay, so today's Delta Math assignment, you're going to practice filling out a few big X problems like factoring, and then you'll practice putting equations in standard form.